The Anaheim Ducks bought a new jet so they can travel to games faster. It cost the team $5 million for the jet. With the current frequency they travel to games, the jet is expected to depreciate in value by 10% each season of hockey. The explicit rule would be 5 million times 0.9 to the power of x, because 5 million is the start value and 0.9 is the rate at which it depreciates. The recursive rule would be a start of 5 million and it would be next equals now times 0.9. The table has, at 0 seasons, the jet is worth $5 million. After 1 season, it is worth $4.5 million. After 2 seasons, it is worth $4.05 million. After 3 seasons, it is worth $3.65 million, rounded. After 4, it is worth $3.28 million, and after 5 seasons, it is worth $2.95 million. Next is the graph. It shows the value of the jet over 5 seasons. The start is 5 million, and at first it is a fast decrease and slows down over time, and the curve is really slow. The first question is, how much will the jet be worth after 10 seasons? The answer is $1.74 million, up rounded, because if you go into your calculator and type in the explicit rule into y equals and go to the table and scroll down to 10 in the x column, you will see that the answer is $1.74 million. The second question is, when will the jet be worth $926,510? And the answer would be 16 years, because if you again go into the table and scroll down in the y column until you see $926,510 and go over to the x column, you'll see that it's 16 years.
Jim lives in South Africa and records the number of meerkats every year. He notices that each year they double in population. Before he started recording, there were 10 meerkats in 2000. Okay, so the recursive rule for this problem would be next equals now times 2, because the population doubles each year. The explicit rule would be y is equal to 10 times 2 to the x power, and the graph is curved because it's an exponential problem. Question number 1. On what year will the population of meerkats reach 10,000? The answer is between 9 and 10 years, because if you enter the explicit formula into y equals and go to second graph, you can tell which year the population will be 10,000. So question number 2. How many meerkats will there be in 2015? The answer is 327,680, because Jim starts recording the number of meerkats in 2000. So if you go to second graph and go down to 15, the answer is 327,680.
The third problem is, Jonathan loves to play paintball with his friends. Each box of paintballs costs $5. Every round he uses up a whole box. Jonathan arrived with $50 to spend on paintballs. The explicit rule would be y equals negative 5x plus 50, because 50 represents your start value, which would be the y-intercept, and negative 5 would be your rate of change, because he loses $5 every round he plays. And if you substitute in how many games he plays into x, it'll give you how much money he has left after that round. The recursive rule would be next equals now minus 5 with a start of 50. The table would be with an x of 0, your y is going to be 50, and every time x increases by 1, and y will decrease by 5. The graph has a linear decay because he is decreasing by $5 for every game that he plays, and after 10 games he would be completely out of money. The first question is, when will Jonathan have $5 to spend? And the answer would be 9 games, because if you go up to 5 and over to 9, you'll see that there's a dot there on the line. The second question is, how much money will Jonathan have after 6 games? And you can see this by going to the graph again and going over to 6 and up to the dot you see and going over to see that he will have $20 left.
Bob is trying out for the track team and wants to improve his ability on long distance running. He can already run 5 minutes straight without stopping. Each day he adds 2 minutes longer to run continuously. On day 1 he runs 7 minutes, on day 2 he runs 9 minutes, and so on. This problem is an example of linear growth because it adds on something each time. So in the table you can see that each day he adds 2 minutes longer that he runs. In the graph you can see that it's discrete because he doesn't run continuously. The recursive rule is next equals now plus 2, and the start is 5 minutes because he can run 5 minutes on the first day. The explicit rule is y equals 2x plus 5. For the first problem, it's using the explicit rule to determine how many minutes he'll run on day 30. The answer is 65 minutes. You can solve this problem by going into your calculator and entering the data on the table and scrolling down to 30 on the x column and looking at what the y is. For problem 2, on what day will he run 55 minutes? And the answer is day 25. You can do the same thing by going and entering the data into your calculator and going down to see that on day 25 he runs 55 minutes.